Good morning, everyone. My name is Dipali Jain. I'm a student of LJMU. Today, I'm going to present my final thesis topic on enhancing information extraction and profile recommendation using advanced vector embeddings and similarity measures under the supervision of Dr. Sashi Prakash Tripathi. So let's start. One of the key challenges of the 21st century is unemployment, a multidimensional social and economic phenomena. Every month there is about 1 million people lands into the job market. Finding the best fitted person with appropriate skills has never been an easy feat for organization. It requires recruiters to splash through thousands of resumes. Early elimination of irrelevant profiles help reduce hiring time, efforts, and cost. Traditional recruitment methods are outdated, slow, and prone to human error. Modern recruitment faces data overload, demanding smarter, scalable solutions. AI and ML technologies enable intelligent matching and understanding context and relevance. This research focuses on improvement of job description alignment using NLP and vector based similarity models. So, our background of this research is that we are proposing AI/ML system which could tap into the profile screening process by extracting information from a semi-structured resumes like skill set, experience, accolades that is effective for data for profile recommendation for a given job description. Our aim and objective is to develop an AI ML system that automates resume job description matching. Objective: analyze traditional versus AI ML systems, design ML and DL models for info extraction, evaluate accuracy and scalability. So, if we talk about the literature review, information extraction, extracting relevant features or information from resumes and job description, mainly different types of research done earlier in this space. One of the first approach is to consider the keyword retrieval to screen out the resume which are not of use. Second, published studies tried to learn the information extraction rules for resume using XML tags to identify key attributes, namely email, name, street, province, etc. Lastly, few studies shown information extraction is a combination of syntactical and semantical entity recognition task. Vector embeddings and similarity. Word vector embedding is nothing but a vectorial representation of a word in a 10 to hundreds of dimensional vector space model. Word to vec, low vector, and fast text are the popular framework to generate word embeddings. Measure of distance or similarity can be computed between two vectors. Few most popular similarity measures such as cosine similarities, Pearson coefficient, Jaccard similarity, etc. Literature review. Recommendation engine are the machine learned models that provide recommendations. The main objective of recommendation engine is to provide suggestion to its user base with a highly relevant set of items. The idea of context based recommendation is the recommend items to users based on similarity between user sets and the item information. Collaborative filtering relies on finding people similar to the target person and recommending items which similar people have liked. Content based versus collaborative filtering. Collaborative filtering focus on users behavior, whereas content based filtering focus on item features. It recommend collaborating filtering recommend items based on the what similar users like. For example, user A and user B liked the same article and user A liked another new article that is now recommended to user B even they have never interacted with it. So the advantage of this collaborative filtering is learns from user interaction, and and the disadvantage is struggle with new user items. It's called a cold start problem. Content-based filtering focuses on item features, recommend items similar to what the user liked in the past. For example, if user A reads an article, the system recommend another article with similar context, keywords or topics. Here, system recommend works well with limited user data, may lack diversity in recommendations. Research methodology. The fundamental objective of this research paper is to find the best fitted candidate resume from a pool of millions profile based on the particular job description. Our proposed model works in three different loosely coupled stages. First, it extracts the information from unstructured resume, convert it to a structured format. Second, it computes the similarity between the processed resume text and clean job description. Third, it makes a recommendation to the recruiters. We have done a comparative study of three different unsupervised machine learning techniques using vector embedding and distance computing algorithm like TF-IDF vector with cosine similarity, K nearest neighbor with Minkowski distance, doc to vec with cosine similarity. Hierarchical structure of the resume. Here is the hierarchical structure of resume. It's divided into qualifications, skills, experience, competencies. So a resume is a mostly semi-structured data. No, normally it has a document level ordered hierarchy. Features below illustrate the hierarchical structure of a resume. Text pre-processing in simple terms is to bring down the raw text into machine understandable, predictable, and analyzing form. For this kind of things, we use tokenizations, lower casing, stop word removal, lemmatization, noise removal, pause text tagging. Information extraction pipelines start with the usual text pre-processing steps, sentence segmentation, tokenization, and POS tagging. We thought of resume as a composition of four sections, that is qualification, experience, competencies, job description. With the help of POS tagging and LTK spacey, we have extract mentioned sections from each resume and exported those into a clean CSV file. So model development and recommendation, as we have already told you, that content-based recommendation using TF-IDF and cosine similarity, it's a most common weighing method used to describe document in a vector space model. This measures that is often used when dealing with textual data to information retrieval, in particular for text mining and calculate document similarity or to find relevant documents from a pool of documents. K nearest neighbor with a Minkowski distance. This concept of nearest neighbor is to find a predefined number of training samples closest in the distance to the new point. Model development and recommendations. Here recommendation using doc to vec and cosine similarity. The main objective of doc to vec algorithm is to generate an array of vectors to represent a paragraph or a document. Our problem is to find a text similarity. So in our paper, we have gone with content-based recommender where the job description given by the employer, it is matched against the content of the resumes in the vector space, and top and closely matching profiles are recommended to the employer. Our model is developed with the help of distributed memory version of paragraph vector. Then it computes the cosine similarity between every document vector of a resume and particular document vector of job description, and with that of our proposed model recommends the top 10 most similar profiles to the recruiter. Model evaluation. To access a doc-to-vector recommendation model, we'll first infer new vector for each document of the training corpus. Compare with the inferred vectors with the training corpus and then returning the rank of the document based on the self-similarity. Basically, greater than 91% of the inferred document are found to be most similar to itself, and about 9% of the time it is mistakenly more similar to the another document. So this is the architectural design of our whole project and research. It starts with resume, then it goes with resume parsing step, then we filter the skills and job descriptions thing, and then resume vector embedding, vector relational similarity using cosine distance, then job description. Here we used a doc to vector method. Job description databases convert to job description embedding, and then it is feeding back to the vector relational similarity, then coming to the recommendation engine, then top 10 matching resumes goes to human resource department, that is HRD. Results and discussions. K nearest neighbors with Minkowski distance. Below the table shows K nearest neighbors of top 10 recommendation. We are computing similarity in the nearest neighbor algorithm with the help of Minkowski distance. The interpretation of the score is less than the distance, the more the similarity between the job description and resume. So the score is like the less the distance between the more similarity between if the distance is less, there will be a more similarity between the job description and resumes. To make it comparative study between the mentioned three approaches, we have considered the same job ID and to draw a clear view about our model. Next, we used this IDF vector and with cosine similarity. This illustrates the recommended profiles. Here, the similarity has been computed using cosine similarity. So the score should be interpreted like more the score, the better matching between the job description and resume. Third, we have used doc to vec with cosine similarity. Here, it is also more the score, the better the matching between the resume and the JD. And this given an idea about the content-based recommendation made using doc to vector and cosine similarity. So we have used three techniques. Now the conclusion and the future scope for this research is we have shown a comparative study of different approaches, but there are a lot other ways exist. We believe this particular field of resume recommendation based on job description has a great scope and a future work such as using other similarity metrics, collaborative filtering and hybrid recommendation system could be used with some changes in data pre-processing steps that will lead us to compare our study on a much broader scope. Other word embedding techniques like fast text, glow vector could be used. Consider usage of deep learning based recommendations. Last but not the least, a millions of resume could cloud help any experiment with scalability. So we can assume the future scope of this project is very high. Thank you. Thank you for listening my profile for research.